Okay, morning class. I hope all of you can hear me. If you can hear me, let me know. If you can't hear me, also let me know. Hello, morning class. Can you all hear me?
Morning, sir.
Morning. So can
Morning,
hear me
sir.
lah. Okay, good then. I already shared the StreamYard thing. I hope that you can hear and see. Okay, hold on. Just give a second. I'm in the college, so need to set up line here. Teaching online is not that hard, but setting up is very hard. Set up line here. Okay, the one in StreamYard also, they are there already. Morning. Okay, Diviana. Morning, 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 morning. Gan. Okay, cool. So everybody can see me and can hear me. Okay, good then. So just give me a second. Let me set up. Then we start. Hope that this works. Hold on. Okay, so you all can see, right? Okay, can everybody see the screen?
Yes.
Okay, that's good. Screen, Windows, StreamYard. Okay, those in what is this called? In YouTube also, you all can see the screen, right, class? Okay, I'm very sure those in YouTube also can see the screen. So this is where we stopped last. We're going to carry on from sum of infinity right now, right? Okay, I'm going to carry on with sum of infinity. Hope everybody ready lah. Let me just check. Okay, okay, cool then. So I put this way, I guess better for everybody. For those in YouTube, if you all can hear me and can see the screen, say Yahoo. So we can begin now. Okay. Just give a second, then we start. Okay, 5 minutes time we start. Now 23 of you all there, and how many of you all in Zoom? Let's see. 23, 40, so 63. Still waiting for some more, the others to come in. Then we start. Oh, nice, huh? You all can say Yahoo also, huh? Good, huh? Hopefully your weekend was good, huh? Everybody? Idanish, Falisha, Nurul, Nadira. Hopefully your weekend was good. Those in Zoom also, hopefully Belden, Kelvin, Hata, Miza, hopefully your weekend was good. So we start in a while. Let's enjoy some music. Okay, so I think enough time given lah, so we start lah. Okay, for those who are here, good morning, and let's begin the class. I can see many of you all join YouTube today morning, so hopefully you all can see and hear in YouTube lah. Okay, and I can see only 30 of you all join the Zoom. Okay, the Zoom is still available, so whoever want to join the Zoom, you all can join. Okay, there's 100 people who can sit in Zoom lah, no problem. Okay, let's carry on now. But I don't advise 100 people be in Zoom lah, then it'll be too heavy. Okay, so be around 60, 70 is okay lah. Okay, then cool. So if I carry on, ready, everybody? So let's start. Uh, we are going to carry on back with S infinity. Okay, S infinity for geometric sequence. And S infinity is something which you have studied, which is infinite sequence lah. Okay, infinity here means just infinite sequence. Okay, infinite sequence. Okay, so under an infinite sequence, we know that the R must be a fraction because it's between negative 1 and 1. So anything between negative 1 and 1, it can be a negative fraction, it can be a positive fraction, okay, or decimal between negative 1 and 1, then it's a R lah. Okay, we consider that as R over there. So I hope until there everybody clear. Okay, now the reason is if you look at the original formula for Sn equals to a 1 minus r power of n 1 minus r. When n goes to infinity, okay, this whole thing becomes 0. So here we get a over 1 minus r lah. A 1 minus 0. So 1 minus 0 is 1. A times a 1 is a. So a over 1 minus r over there. Clear? So that is when this n becomes infinity or infinite. Okay. So let's see over here. We see one example over here. 2 half 1 over 8, 1 3 over 2. So 2 half 1 over 8. Of course, this is a geometric sequence. This is for sure, confirm. Okay. And then 1 over 32. So from here, we know the A is 2. The R is going to be 1 over 2 divided by 2, which is 1 over 4. So from here, I can tell you if S infinity is going to be 2 over 1 minus 1 over 4. So 2 over 3 over 4, which is just 8 over 3 lah. I hope until here everybody understand this lah. No problem with that. Okay, class, can? Okay. Okay. Let's see the next second example then. They say what is the sum of infinity of the first term is 500 and the common ratio is 2 over 5. Okay, that's quite easy also. S infinity again, the first term is 500 over 1 minus 2 over 5. Yes or not? So 500 over 3 over 5. So 2500 over 3, which is just 833. Okay, 8331 over 3 then. So I hope until here everybody understand lah. That's clear lah. Okay, that's quite easy. It's not that hard. So uh, the B there, I think you all can do. So I'm not going to do. Okay. We go on some more, little bit more here. They say the sum of infinity of a GP is 7. So S infinity is 7. And the sum of the first two terms is 48 over 7. So A plus AR is 48 over 7. C. When they give you equation like this, you follow the equation. Understand? You write down whatever is inside the equation and then from there you follow. So from there you can see this is just A over 1 minus R. Am I right? So if I cross, I get A equals to 7 minus 7R. I can substitute that 7 minus 7R plus 7 minus 7R R equals to 48 over 7. From there, you can solve this equation simultaneously. Okay, Arifa, ready, Arifa? Uh, okay, looks like you are busy preparing water for yourself, maybe. Okay, so from here, you get 7 minus 7R plus 7R minus 7R square equals to 48 over 7. Of course, I can times everything by, what is this called? 7 and get a quadratic equation. And from there, I will get the R value. The R value there is going to be negative 1 over 7 and R equals to 1 over 7. Now, since they tell you the common ratio is positive, then we take R equals to 1 over 7. But if they never tell, then we have to accept both. Okay, so if common ratio is positive, the first term is going to be A equals to 6 there. Substitute back inside the formula. So we use back simultaneous equation. And if you notice one thing, what we do over here is we have the two equations we solve simultaneously. Understand? We have two equation. Equation number 1, equation number 2, then we solve simultaneously. Any problem until here, class? Before I move on, class, any problem until here so far? Hello, any problem until here, class, so far?
No, sir.
Okay, if no, then I move on. Now, the next part here is going to be when they give you a certain decimal number, which they want you to change it to fraction. So if you press in your calculator, it will not be able to change. And this can be written as 1.6, a line at above there, or is the same as writing 1.6 with a dot above, or is the same as writing uh, 1.66666 dot dot dot. Okay, more than more than three dots line. If more than three dots means infinite. Okay, more than three dots or two dots also means infinite lah. Okay, so I hope that's clear. Actually, three dots itself means infinite. Okay, so from here you can tell me that this thing here can be written as 1 plus 0.6 plus 0.66 plus 0.666. So this part here is going to be as infinity. So from there we can write down 1 plus 0.66 divided by 0.6. The R is 1 over 10. Okay, so 0.6 over 1 minus 1 over 10. So here you get 1 plus 0.6 divided by, or 6 over 10 divided by 9 over 10 there. Okay, so 6 over 10 divided by 9 over 10, which is 1 6 over 9. Okay, you don't believe, you can press your calculator. 1 divided by 3 there, 2 over 3. That's very obvious already lah. Clear until that? So from there we get the fraction also, 1 2 over 3 over there. Can you all see that? Of course, you can write 5 over 3. If they ask you to write improper fraction, you write 5 over 3 there. Okay, can everybody? Did I write down wrongly? Oh, sorry, my mistake here. Thanks. Yeah, I agree with you. Okay, this is supposed to be 0.06 and then 0.006. Agree with that, Ung? Okay, thanks, Ung. Okay, very good, Ung. Okay, so yeah, I wrote down wrongly a little bit. Okay, 0.06. Yeah, okay. So I hope until that everybody okay. Can everybody? Okay, now let's see if I give you 5.549. Okay, 5.419. then 5 9. Only the 5 9 only got line. So this one 5.4 is just leave it as 5.4 plus with 0.59 plus with 0.0059 plus with 0.000059. So again, this part here is going to give me S infinity. So I know the A is 0.59, the R is going to be 1 over 100. How? 0.0059 divided by 0.59. Okay, so you get 1 over 100 there. From there, you can calculate 5.4 plus with A 0.59 over 1 minus 1 over 100 there. From there, you get 5.4, or we can change that to fraction, which is 54 over 10 plus 59 over 99, 59 over 100. Okay, 59 over 100 divided by 99 over 100. Can cancel. From there, you can plus the thing and get the final answer over there. So 540 plus with 59 there. Okay. So from there, you can tell me lah the final answer there. This is 990, is it? Yeah, 990 there. No, 99 over 100 first. Yeah, correct. Okay, so from there, you will get the final answer there. So I hope until there, everybody okay. Any problem until there so far? Everybody okay until there so far? Class, are you all okay? Oh, sorry, here, my
Okay,
mistake
sir.
here again. Yeah, 0.059. That's why I'm not getting the answer. So here, supposed to be 0.059. Okay, so here also supposed to be 0.059. Okay, so I think got one extra zero here. So yeah, okay. So that's how you find S infinity lah. Okay. Yeah, the A is 0.059 there. Correct, Hatta? Correct, Venetia? Okay. So must be very careful line, morning line. Okay, that's right. Okay, so that is what S infinity stands for lah. Okay, that's what S infinity stands for. The balance questions there you all can see, no problem. Okay, I will not go through into more detail over there. Okay, for the balance question because I feel that that is quite easy. You all should be able to do yourself. Okay, now we want to go on to the next part of the chapter. Okay, the next part of the chapter is going to be binomial expansion. Okay, binomial expansion. So ready for the next part? This is what I want to concentrate a bit more inside lah. Okay, now binomial expansion comes from Pascal triangle. Okay, binomial expansion comes from Pascal triangle. You might have studied a Pascal triangle before. Okay, so this is where binomial expansion comes lah from. Okay, there's a formula which we have to follow lah, which we have to follow. Now the reason we study binomial expansion is for one of the main reason is because of probability. Okay, the expansion will give us the probabilities. The second thing is to predict. Okay, it's a prediction which we use a lot recently, especially when there's a pandemic. Okay, when there's a pandemic, economy growth. Okay, economic growth, and then maybe health system. Okay, we also will see population growth. Okay, how many people die and how many people live a day. Understand? So it's all about prediction of pandemic, economy, health system, population. If you really know how to see the sequence or you can see the binomial expansion nicely, you'll be able to see how actually this will help us in your future lah. Okay, and for those who actually really interested in mathematics, this is called data science lah. Understand? This is called under data science. So when you go and study data science, this is actually very helpful lah. Okay, of course this is just part of it lah. Okay, let's see how does this work. This is what we call a Pascal triangle. Pascal triangle is a European name lah. Okay, it comes from the famous Pascal, Sir Pascal. Okay, so that's where the name comes from. Okay, for Asians they call it Meru triangle. Okay, Meru triangle. Okay, then for Arabs, they call it Shazan, if I'm not mistaken, Shazan triangle. Okay, so there is few names which they can give you lah for this triangle here, but we remember as Pascal triangle lah. Okay, we remember as Pascal triangle. Now, what is the beauty of this triangle over here is this here, this part here. If you look, okay, we start with 1, and then here is 2. Okay, 1 1, then 1 plus 1 will give you 2. Okay, then you add 1 1, then 1 plus 2 will give you 3. Okay, you add this will give you 3 3, so 1 3 3 1. Then you add here 4 6 4. Then you can add here 9 10 10 and 5. This is what we are going to play with lah. Okay, and if you really look at this is expansion of a plus b square, such that you get a square, which is 1 in front there, coefficient is 1, plus with 2ab, the coefficient is 2, plus with b square. Can see that? This one everybody should know how to expand it, right? This one you learn how to expand in form 2, yes or not? So you already know how to expand this lah. Okay, but right now it's just that telling you how the expansion actually came in lah. Okay, of course, if they give you a plus b square, you're not going to use Pascal triangle, but I should tell you lah how this thing came in there. Okay, okay. Now, there is a lot of other stuff which we can see also that Pascal triangle give us. Okay, you can see that the addition of numbers will give you a certain amount of numbers. Okay, and this triangle is still today is been still identified lah. It's still been experimented by the scientists, okay, or by mathematicians to find out what are the beauty of the numbers which we have here. Okay, for that I did send you all a video, okay, in your lecture group and in your tutorial group also. You all can watch the video lah. Okay, if you watch the video you can see how that what this triangle is been this one lah. Okay, been applied. Okay, the beauty of this triangle. So I already talked about the history of this triangle. Let's go on a bit more into how can we expand this formula. Okay, this formula expansion is very simple. A power of b, a plus b power of n can be written as n0, a power of n, b0, n1, a power of n minus 1, b power of 1, n2, a power of n minus 2, b power of 2, and so on. Okay, and actually you have seen this before. You've seen this in your binomial expansion where you all use this formula NCR. Remember this? You study this in binomial distribution in Form 5, Chapter 9, I think. Okay, under probability distribution. Okay, so you study that at NCR there where you learn how to calculate binomial distribution. Okay, uh, so let's see more detail over here a little bit. Okay, we look at this thing here. Okay, 2 plus x power of 5 here. So 2 plus x power of 5, if I want to use Pascal triangle, can, no problem. Okay, I just need to go to the fifth line. So this is the first one. This is the second one. Okay, this is the third stage. This is the fourth stage. And this is the fifth stage. So if I go to the fifth line over here, I will know already that the expansion, the coefficient in front will have to be taking place from here, from this line over here. If I use Pascal triangle. Understand? If I use Pascal triangle, let me just try to use Pascal triangle and show you a little bit so you can see that. Okay, so if I look over there, it's 2 plus x power of 5. Yes, sir. Okay, so yeah, sorry lah, the page is too heavy, so that's why. Okay, yes, okay. So 2 plus x power of 5. Now I just zoom out a bit so I can see the green color line for a while. Okay, I hope this is better. So now from there I can see that the coefficient, the first one is 1. Okay, the second one is 5. The third one is 10. Then 10 again. Then 5 and then 1. So what is the middle one? What is the what other stuff which I need to add? Of course I need to add here 2 power of 0, or maybe I put 2 power of 5 better. Okay, x power of 0 means the x is increasing. The power of x will keep on increasing, plus with 2 power of 4, x power of 1, plus with uh, Okay, plus with 10, then 10 after 10 there, 2 again, 2 power of 3, x power of 2. Then the next one there, plus with 2 power of 4, x power of 3. Am I right? No, 2 power of 2, sorry. 2 power of 2, x power of 3, plus with 5 there, 2 power of 1, x power of 4. And last one there, you plus with, uh, 1, the coefficient was 1 just now, 2 power of 0, x power of 5. Okay, now this is how I expand through Pascal triangle. This is how I expand through Pascal triangle. Of course, the answer is going to be the same. Now let's just see if I'm going to explain through our formula. Okay, through our formula, this is going to be 5c0, 2 power of 5, x power of 0, plus with 5c1, 2 power of 4, x power of 1, okay, plus with 5c2, 2 power of, what is this called, 3, x power of 2, 5c3, 2 power of 3, sorry, yeah, correct. No, not 2 power of 3, should be 2 power of 3 and then 2, x power of 3, plus with 5c4, 2 power of 1, x power of 4, 5c0, 2 power of 0, x power of 5. So this is increasing order of x. Whatever is going on here is all increasing order of x and decreasing order of 2. Okay, the 2 there, the coefficient 2 there is decreasing. The coefficient 2 there is decreasing. The power of x is increasing. All the power of x are increasing over here. You can see that. And if you notice one thing, 5 plus 0 is 5, 4 plus 1 is 5, 3, 2, 5, 2, 3, 5, 1, 4, 5, 0, 5, 5. So the total power of the index is 5, which is the binomial expansion of power of 5. Understand that or not? Clear? Okay. Now, what I want to show you over here right now is this part here. If you look at this 1 over here, it's the same as this 1 here. 5c0 is 1. 5c1 is 5. 5c2 is 10. 5c3 is 5. And then 5c4 there, wait, 5c4 there is 5, my mistake. 5c3 there is 10, okay, got two tens, right? 110, 110. Then 5c4 there is 5, okay, and 5c0 is 1 again, or 5c5, this one's supposed to be 5c5 actually. Okay, 5c5 here is 1. Can see that? So basically these combinations over here are the coefficient of your expansion. These combinations over here are the coefficient of expansion. That's why we say that we use this in probability or prediction of events and all this. Can you all understand until here so far, class? Any problem? Any problem, class?
No, sir.
No.
No, Okay, if no problem, then good. I hope everybody clear. Okay, those in YouTube, any questions inside here so far? I'm waiting. Yeah, those in YouTube, are you all okay, class?
Sir,
Yeah, say.
jawapan dia tambah semua tu lah kan? 1 tambah 5 tambah 10 tu ke apa?
Jawapan dia kita kena kira satu persatu. So if I want to calculate the answer, 5c0 there is 1, and then 2 power of 5 is 32, yes or not? Okay, x power 0 is 1 lah, so no need lah. Clear? Okay, plus with 5c1 is 5, 2 power of 4 there is 16, and then x. Okay, plus with 5c2 is 10, 2 power of 3 is 8, x power of 2. and then plus with 5c3 is 10, 2 power of 2 is 4, x power of 3, plus with 5c4 is 5, 2 x power of 4, 2 power of 1 there is 4, yes or no? 2 power of 1 is 2, sorry. Okay, 5c5 is 1, and then 1, and then x power of 5. So your final answer will be 32. 5 times 16, berapa? If you calculate that, you're going to get 80, if I'm not mistaken, 80x plus 80x squared plus 40x cubed. If I calculate wrongly, please let me know. Okay, plus 10 x power 4 plus x power 5. Ini lah jawapan akhir dia. Boleh faham sampai sini? Jawapan boleh tekan calculator dapat. Tak ada masalah. Okay. Yang penting adalah sini. Bahagian sini penting. Okay, bahagian sini penting. Any problem until there so far?
No, sir.
Okay. Okay, if no problem and everybody okay, I move on lah. Okay, I move on a bit. Now, before I move on to the examples or the type of things, okay, we want to look another one more thing here first. It's called definition of a factorial. This is important. Okay, this is important again lah. Definition of a factorial. You have studied this definition before. Not say you never study. Okay, let's say for example 5 factorial. This is 5 times 4 times 3 times 2 times 1. So this is called 5 factorial. If I give you 9 factorial, of course, 9 times 8 times 7 times go on all the way until 1. Now, why the reason I want to go to this definition? Because later you will see the definition of factorial plays a part in binomial expansion. Okay, now let's see if I give you like this, n factorial, then how? Oh, this is, don't start with n line. I think I prefer to start with 1. 1 times 2 times 3 all the way till n. Okay, of course before n is what? Before n is going to be n minus 1. Before n minus 1 is what? If you want me to write, I can write 2 3 times dot 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 times n minus 2, n minus 1, and then n. Clear? Times. Some people, they like to start with n. So if let's say I write n factorial, when they start with n, it's going to become n times with n minus 1 times with n minus 2 times with all the way 3, 2, 1. Understand? Why? Because they prefer using this way. But we all know, right? You start from 9 times 9 all the way till 1, or 1 all the way to 9. Is times what? Right? No, doesn't matter whichever you times first. So same goes with this. This and this is the same thing. Can you all understand until here so far, class? Boleh sampai sini?
Boleh.
Boleh, sir.
Okay, bagus. Now, if I give you, how about this one? N minus 2 factorial. Oops, sorry. Okay, how about n minus 2 factorial now? If n minus 2 also, I will prefer to start with 1. Yes or not? If I start with 1, I get 1 times 2 times 3. Go on. Don't stop at straight away n minus 2 lah. Put lah n minus 3 first. Then only n minus 2 lah. That's how you should do lah. But if you want to go the other way around, also can. Okay. N minus 2, then n minus 3, then n minus 4. Yes or not? And all the way till 3 times 2 times 1. Okay. Now, Jing Suang asked me, why is it not n plus 1? Why the reason is not n plus 1? If you look over here, this number is increasing. Yes or not? If the number is increasing, here is n. So, of course, the number before that must be lesser by 1, right? Yeah, if here is 3, the number before that is lesser by 1, what? 3 minus 1, what? So, it have to be n minus 1. Understand that, Jin Suan? Clear? Okay. And even the same thing over here. If this is n, I start from here n, you see, 9. Then the next number here is 8. So, it's minus 1. Then minus 2. Then minus 3, right or not? So, that's why. Clear? Okay. Okay, so I hope I answered that question. Did I, Jin Suan? Okay, I answer your question there. Cool. Okay, now To get back to Jinson's question, we can even increase the question a little bit. Okay, we see like this. How about this? N plus 1 factorial. So if n plus 1 factorial, I can write this as n factorial times with n plus 1. Why? Because n factorial can be written as 1 times 2 times 3 all the way till n. Then n plus 1 means must times with n plus 1 some more, right? That's why. Clear? So n plus 1 factorial can be written as n factorial n plus 1. So I hope until there you all are clear. Why is this important? Because sometimes we see question like this. They ask to simplify. Okay. They ask to simplify lah. I'm just putting questions. Okay. Hopefully it works. Okay. So we know that n plus 1 factorial can be written as 1 times 2 times 3 dot 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 times n plus 1 from the top there already. N minus 2 factorial can be written as 1 times 2 times 3. Okay, dot dot dot. Okay, this one maybe I don't want to put factorial here. Okay, times n minus 2. Right, n minus 2. Uh-huh. Then here is n minus 1. So let's go back a little bit at the top there and write back some numbers before the n. So n minus 2 times n minus 1 times n plus 1 over 1 times 2 times 3 times all the way till n minus 2 and then n minus 1 there. So you can see one thing that this part here, the green color part and the green color part here will cancel off. Am I right? These two parts will cancel off. And then you also can see this n minus 1 and n minus 1 will cancel off. Am I right? Can divide, right? So when you divide, it will cancel off. So left only the balance is going to be n and n plus 1, which is just n squared plus n. No? Done. Any problem until here? So this is called simplifying of factorials. No? Okay, this is just called simplifying of factorial numbers. No? So that's why the reason, one of the reason we study this. No? Okay, let's just look over here a little bit. Okay, under the definition of binomial coefficient also, remember just now we write down NCR. The NCR over here, the general formula for NCR is actually n factorial over n minus r factorial, r factorial. I'm not sure if your school teacher got teach you all this or not before, but yeah, this one is covered in your SPM when you study binomial expansion. Okay, binomial distribution. So NCR there, not binomial distribution, sorry. And when you study combination, my mistake. When you study combination. So NCR over there is n factorial over n minus r factorial, r factorial. Remember permutation combination? Permutation we use P, yes or not? So under combination we use C. Of course we can press the calculator lah and the shift divide button. We press the shift divide button, we will get the C already. Correct or not? But this is actually the general formula. So if last time people didn't have calculator, this is how they calculate lah. 5C2. So 5C2 can be written as what? Okay, 5C2 there can be written as 5 factorial divide by, look at the formula, 5 minus 2. So 5 minus 2 is 3 factorial times with 2 factorial. Now, I know I straight away can get the answer 10. I know how to get also, but I just want to show you something. This is what happened over here. 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times with 2 times with 1. So you can see again, see 2 and 1, 2 and 1 will cancel. Okay, 3 here will cancel with the 3 here. So left only what? 20 divided by 2, which is just 10. So actually you can calculate using your calculator. Yes or not? I mean, you can use your calculator and calculate, but if let's say lah, calculator is not given or there is a quiz which tells you 5 times 4 times dash times 2 times 1. So you should know lah what is the dash number missing over there. Clear? That is what if you go for higher level quizzes, that's what how the way they ask lah. Okay, and combination is very good, right? Sometimes remember they ask you to find the number of triangles. Okay, they say, oh, here got this many, find for me the number of triangles over here. You should be able to find what, right? Clear until that? Okay. Okay, let's carry on some more. Okay, so I will move on next to, wait, no, wait. Let me go back again and let me give you some notes some more. Okay, now before I go on some more to binomial expansion, I want to break up this binomial expansion to three types for you. Okay, it's going to be type 1. Okay, type 1 is such as this: ax plus b power of n. Okay, where n is positive integers. Okay, positive integers means 1, 2, 3, 4, and so on. Okay, positive integers. Only positive integers. Okay, I stress again, or positive whole numbers lah. Better, I think I use the word whole number instead of using integers. Whole numbers. Okay, positive whole number or natural numbers lah. Okay, why? Because there is a different rule for fraction after this. Okay, there's a different rule for fraction after this. So now then we got type 2 over here. Type 2 is, okay, x or a plus b there. Okay, ax plus b over there. Or I think I better use like this. Let me just use 1. This can be minus also, doesn't matter. This is 1 plus or minus. Okay, ax power of n also. But this time, the n here is going to be negative whole numbers, or the n is going to be fractions, positive or negative, can be any one of it lah. Okay, can be any one of it. So that will be type 2. Okay, that will be type 2. Then we got type 3. Okay, now before we go into type 3, let's see type 1 first lah. Then we will see type 2. Okay, don't worry, we see type 1 first. I give you some examples for type 1, then we see type 2. Ready? So type 1 over here, let's say if I give you 3 plus 2x power of 7. Okay, power of 7. And I just tell you to expand this thing, expand to the fourth term. Okay, now listen very carefully. What's the meaning of fourth term over here? Fourth term over here will be including x power of 0, x power of 1, x power of 2, and x power of 3. Means until x power of 3 only. The fourth term over here means just until x power of 3 only. I don't want you to expand everything. I only want you to expand until x power of 3 only. Okay, so if I use my formula, I know my formula is 7c0, 3 power of 7, 2x power of 0, plus with, be careful, 7c1, 3 power of 6, 2x power of 1, plus with 7c2, 3 power of 5, 2x power of 2, and plus with 7c3, 3 power of 3 power of 4, yes or not? Yeah, and 2x power of 3. Of course, we put the plus dot 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 dot. Why? There is some more, okay, but just that we don't want. We only want to expand until the fourth term. So this is the first term. Then after that, followed by this is the second term. Then followed by this. This is the third term. Third term. And then this is followed by the fourth term. Can you see that? Okay. Of course, in increasing order lah. Of course, in increasing order of x, power of x. So from here, we know 7c0 is 1. 3 power of 7. Can you all please calculate? Anybody? 3 power of 7. Can I get the answer, please?
2187.
2187. Okay. 2x power of 0 is 1. Don't write 0, 1. Plus with 7c1 is 7, if I'm not mistaken. 3 power of 6. Anybody else? Yep, 3 power of 6 class. I'm not going to calculate that. Again, Miza?
729.
729. Okay. Here is going to become 2x only. Why? Because 2 power of 1 is 2, x power of 1 is x. Okay, plus with 7c2. Oh, 7c2, I forget already. Anybody can tell me? Help me with 7c2 over there. Anybody can help me with 7c2, please?
21.
81 or 21?
21.
21. Okay. 3 power of 5. Yep, I'm waiting for your answers. 3 power 5 there.
2 for 3.
Again.
2 for 3. 2 for 3.
Okay, 2 for 3. And then 2x power of 2 there. Be careful. This is 4x squared. Okay, plus with 7c3. Anybody?
35.
95. 95.
35.
35. Okay, 35. And then 3 power 4 there, if I'm not mistaken, is 3 power 4 is going to be 243, right? No.
81.
Huh? 3 power of 3 is 27. Sorry, 81. My mistake. 2 power of 3 is 8x cubed. Yes, correct. Plus with dot dot dot. Okay. Now, of course, don't tell me you're going to leave the answer like this. Of course, you have to calculate all of this also. 2187 plus with 7 times 729. You write down. Okay. 7, 729, and 2 times all that. And then 21, 2, 4, 3, and 4 times all that. 35, 81, and 8. You times all that and write down. Any problem until there, class? So that expansion, I will leave it to you. Okay. That expansion there, I leave it to you. Any problem until there so far, class? Can class?
Sir,
Yes, say.
boleh tak kita expand sampai ke X4?
Kalau dia minta boleh lah. Kalau dia if I never tell you, that I need until x power of 4, okay, x power of 7, if I never tell you that I need until the fourth term, then you have to expand all the way until x power of 7 lah. No problem lah. Understand? Clear?
Okay.
Okay. Can, right? Okay. Any more problem over there? Okay. Any more question inside there? Some more?
No, sir.
No. Okay. So if no, then this is type 1 lah. Okay, let's see another one more. Okay, this is more interesting little bit. I make it a bit more complicated. B there. Okay, let's see if I give you 1 minus 2x power of 5. Okay, now we try to expand everything for this because I never say anything, right? Not okay, because I never tell you anything. Okay. Nazir tak datang. Tapi dia Nazir datang lagi ni. Tak ada message pun. Dia pengarah cakap tadi. Saya nak tahu betul saya sibuk nanti Sunday nak interview hari ni GC. Okay, so now let's see the next part here. 1 minus 2x power of 5 there. So if I expand this thing here, I get 5c0. Okay, 1 power of 5 negative 2x power of 0 plus with 5c1 1 power of 4 negative 2x power of 1 plus with 5c2 okay 1 power of 3, yes or not? Then negative 2x power of 2 5c3. If I'm wrong, please correct me. 5c3, this will be what? Anybody? 1 4 5 4 3 2. This will be 2 negative 2x power of 3 and then plus with 5c4 1 there power of 1 negative 2x power of 4 and 5c0 1 power of 0 and negative 2x power of 5. Now look over here. This is increasing order of x. The only thing which I want you to be careful over here is this negative over here. This negative over here is very, very important. Okay. Now, if you look at the first one there, no problem lah. 5c0 is 1, 1 power of 5 is 1, negative 2x power of 0 is 1, so 1 lah. But the second one over there is 5, then 1, negative 2x power of 1. So this becomes negative 2x. So that will change your answer after this. Okay. Then 5c2. If 5c2, I know just now that the 5c2 is 10. Yes or not? Okay, 1 is 1 still. Negative 2x power of 2 there, that will become 4x squared. Because negative 2 and then power of 2. Negative 2 power of 2 is positive 4, right? Clear? So 1 now becoming negative, 1 more becoming positive. Then again, 5c3 there, again 10. 1, then negative 2x cubed there, so it's negative 8x cubed lah. Okay, 5c4 there is 5, 1, negative 2x power 4 there is going to become 16 lah, x power 4, plus with 5c0 there is 1, uh, 1 again, negative 2 power of 5 there, negative 32x power of 5. So if I just, yeah, I need to extend the page here, then I can add the page to the colon, hopefully. Yes. Okay, so if I can see this, hold on, it will take some time. iPad too heavy already, okay, now here. So from here you can see this will become 1 minus 10x plus 40x squared minus 80x cubed plus 80x power 4 my minus 32x power 5. This is your final answer lah. Clear? This is your final answer over there. Understand until here so far? Can? So you can see that over here, one is positive, one is negative, one is positive, negative, positive, negative, positive, negative. Why? Because of the negative over there. So just to take note over here, if you really look at the formula of expansion, this is your A. Whatever I color here, this thing here is your A. Whatever I color with the blue color one, this is your B lah. Okay, wait, I just want to color the symbol also. So the positive 2x there is your B. Over here, so this is your A. Okay, sorry. I should have colored with the same color, right? This is your A, and this is your B over here. Can you understand until here so far? Any problem until here so far? Can? Hello. Okay, good then. So if everybody can, we will stop here today. Okay, Jinswan, to just answer your question there. Yes, you leave dot dot dot, but of course you have to find the final answer here lah. This one I never calculate. You press your calculator and calculate. Clear with that, Jinswan? Okay. The others, I think I already answered your question. So yeah. Okay. If you got any other question, please do ask me lah. Okay. Please do ask me. Understood? Okay. Very good. So if everybody understood, then I think I will stop here. Okay, for today, and I will see y'all next week. This Friday lah. Am I right? This Friday for the next class. Then. Okay, this Friday. Hopefully, we will finish up binomial expansion. Okay then, class. Thank you, class. Bye bye.
Sir,
Yes, say.
this is all example for type 1.
Yes, this is just for type 1. I haven't go to type 2 and type 3 yet.
Okay.
Okay. Okay. Cool. Okay then. Bye.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.